In this video, we're going to get some more practice with indefinite integrals and particularly remembering our exponent rules, which, just to recall, remember, if we have 1 over x to the p power, I can rewrite that as x to the minus p power. And if we have the bth root of x to the a power, I can rewrite that as x to the a divided by b power. These will be really helpful to us in this first integration section, just like they were when we first started learning derivatives. So in this first example, we have the indefinite integral of 5 divided by x minus 4e to the x power, and we're integrating with respect to x here. Now, I think we've got kind of two different looking problems. You don't necessarily need to take this step, but I think it would be helpful if we broke this problem up. I'm going to break it up into two separate indefinite integrals. I'm going to write this as 5 over x dx minus the integral of 4e to the x dx. So I think we would probably have a pretty good handle on this integral over here. It's the first one that is tricky here. Let's talk specifically about that. Now, you might look at 5 over x and say, hey, that looks really similar to 1 over x. What if I use those exponent rules that we gave earlier? Well, let's try that. Let's just see what happens. I could rewrite this as 5x to the minus 1 power dx. And then when I integrate, remember our steps for integrating, just to write them down, we add 1 to the power, and then we divide by the power. So we add 1 to the power, we would have 5x raised to the 0 power, and then divide by our new power of 0. And we've got a problem here. You can't divide by 0. So that means our power rule is not going to work out for this particular problem. We can't use it, which means it's going to be one of our other two special cases. And in order to see kind of where that's coming from, I would use the other property of indefinite integrals that said, hey, you know what? If you have a constant multiple, which if you have trouble seeing 5 as a constant multiple, we can rewrite that as 5 divided by 1 times 1 over x dx. 5 divided by 1, well, that's just 5 times the integral of 1 over x dx. Now, all of a sudden, we say, hey, that looks a lot like the derivative of natural log. So that means that the antiderivative of 1 over x would be 5 times natural log. Remember, we need to include absolute value of x. So that's for just kind of that left-hand side. If we kind of split that up into two parts, that's just for that left-hand side. For the right-hand side, I would take a similar approach here where I would factor out this 4. So I would say minus 4 times the indefinite integral of e to the x dx. And then I like to do all my integration in the same step. I'm just going to bring that down, minus 4 times the integral e to the x dx, because then in my last step, that was when I integrated. So I know that the antiderivative of e to the x is just e to the x. The minus 4 is a constant multiple, so that's just going to come down. There's my indefinite integral, but oh wait, have to add a plus c. So this is what my indefinite integral looks like. So be careful, be on the lookout if you have x to the first power in your denominator. Most of the time, not every time, but most of the time, that is going to end up being a natural log function once you integrate it. So let's practice a couple more. Here, these won't be trick questions, I promise you. This time, I want to integrate 5 divided by x cubed dx. Now, if you look back at our power rule, it only told us how to integrate x to the nth power dx. If that power of x lives in the denominator, we don't really know what to do with it. So this is a case where, yes, we absolutely would want to use that first property. So I'm just going to take a step and rewrite this problem. I'm going to rewrite this problem as 5x to the minus 3 power dx. Now I haven't integrated this function, so I still have my integral. I still have my differential dx because I haven't added 1 to the power and divided by that power. Until we've done those steps, those integrals are going to stick around, at least when we're using the power rule. So we think about, okay, what would my next step look like? 5x, I would add 1 to the power. So now we want to be really careful here because we've got negative numbers here. Negative 3 plus 1 should now be to the negative 2 power. And then my second step was I want to divide by that new power. I want to divide by my new power, which in this case is negative 2, plus our constant of integration c. So if you wanted to give your answer like this, I think that is perfectly acceptable. Personally, I don't like negative exponents. You should know this about me by now. And especially if we're going to be doing more work with our antiderivatives once we find them, we might be more comfortable working with positive exponents. So I would probably take a step to rewrite this as 5 over, and the negative sign can go anywhere. It can go in front of the fraction, it can go in the numerator, it can go in the denominator, but I'm just going to stick it in front of the fraction. So I'm going to say negative 5 over 2x to the second power plus c. Either one of these is fine as your answer if you're giving this as your answer on your homework or a quiz or a test. But I do think that there will be situations where we work more with our antiderivative once we find it, and that right-hand side, that positive exponent, is just going to be easier for us to work with. We're going to be less likely to make a mistake there. Let's look at one last example in this video. Here I have the indefinite integral of 4 times the 5th root of u to the 3rd power du. So here I'm integrating with respect to u, which just means my variable I'm thinking about is u instead of x. If you wanted to think about this problem as 4 times the 5th root of x to the 3rd power dx, it's going to look almost exactly the same thing. We're just replacing x with u. But let's keep our variable there. We don't know, and if I look back here, we said our power rule only works if we have x to the nth power. The other two special rules we had, remember, were the antiderivative of 1 over x dx and the antiderivative of e to the x dx. Well, this problem that we're looking at, part C, doesn't really look like any one of these three. But we have those exponent rules that we talked about way back when. Except instead of talking about the first exponent rule, I'm going to want to use the second exponent rule. Remember that I can take any radical or any root function and rewrite it as a power function. So the 4, I would actually factor that out. I don't want to have to worry about that 4 for right now. So I'm going to factor that out. And then I'll write this as u to the 3 divided by 5 power. So we'll say u to the 3 divided by 5 power du. So now this looks a lot more like x to the nth. Which means, hey, x to the nth, that means that we're going to be using our power rule. That means that we want to add 1 to the power and divide by the power. So let's get to it then. 4 I know is a constant multiple, so that's just going to come down to my next step. Let's start by adding 1 to the power. So let's see, I'm going to add 1 to the power. If you need to, off to the side, we can do a little bit of scratch work. 3/5 plus 1 is really, 1 over 1 is the same thing as 5 over 5. So 3 plus 5, I would have 8. Denominator stays the same, so my new power would be 8 divided by 5. So we added 1 to the power. Our next step was, well, divide by that power. Divide by 8/5. And this part right here, this fraction inside of a fraction, makes me sad. I don't really like it. So I think about, okay, what are other ways that I could divide by a fraction? Or if we think back to even when you very first learned how to divide by a fraction, instead of dividing by a fraction, I can say, you know what? Instead of working with that, I can say, well, that's the same thing as 4 times u to the 8/5 power. Instead of dividing by 8/5, I know that dividing by a fraction is the same thing as multiplying by the reciprocal. So I'm going to multiply by the reciprocal of 8/5, which is 5/8. I have to remember to add my constant of integration, so plus c and plus c. And then to finish this problem up, then I'm just going to simplify this part right here, because that's a little bit ugly. I know that 4 is the same thing as 4/1. Luckily for us, for fractions, we don't need a common denominator. So I can take 4 times 5, that would be 20. 1 times 8, that would be 8, times u to the 8/5 power plus c. But hey, these are both even numbers. They're both divisible by 2, so let's divide those out. And actually, I can go even further. These are both divisible by 4. So, okay, let's just divide them both by 4 so that we can do all of our simplifying in one step. 20 divided by 4 would give me 5. 8 divided by 4 would give me 2. I have 5/2 times u to the 8/5 power plus c. So these problems are very, very tricky. Like I've said before, we spent so much time thinking about derivatives, it can be difficult to kind of retrain your brain to think about antiderivatives and indefinite integrals. And that's going to be why practice is so, so important in this section. So towards the bottom of this page, there will be a few extra problems that you can practice, and then I'll go ahead and post the solutions as well so that you can check your answers.